Hello everyone, I'm Aditya Thakre and today I'm going to give my presentation on the topic of polarimeter. Polarimeter is an equipment which is used to determine the concentration of an optically active substance. It is a versatile tool which is used in various fields from chemistry and physics to pharmaceutical and food science. The presentation will cover the fundamentals of polarimetry, then we will look after the working principle and then the types of polarimeter, and then we will also cover the applications and then advantages and disadvantages of an polarimeter. Fundamentals of polarization. So the light waves are transverse electromagnetic waves, meaning their oscillation occur perpendicular to their direction of travel. In unpolarized light, these oscillations are random. However, in polarized light, the oscillations are confined to a specific plane. The polarized light can take different types of forms. It can be linear, circular, or elliptical based on their orientation and rotation of the electric field vector. Optical activity and optical rotation. So the diagram of linearly polarized light passing through a sample with rotating planes show enantiomers D and L forms labeled with rotation directions. Let's discuss the optical activity. The certain molecules known as chiral molecules have the unique ability to rotate the plane of polarization of linearly polarized light. This phenomena occurs due to the molecule chirality or handedness of these molecules, which exist as two mirror image forms called as enantiomers. So, if the compound is rotating the plane polarized light in the clockwise direction, then it will be a D enantiomer, and if it is rotating in anti-clockwise direction, then it will be an L enantiomer. The polarimeter consists of five main components. A light source provides a steady beam of polarized light. The polarizer ensures that the light is linearly polarized. The sample tube holds the chiral substance. The analyzer is another type of polarizer that rotates to match the plane of polarization after the light passes through the sample. Finally, the detector measures the transmitted light intensity to calculate the optical rotation. Working principle. The polarimeter working principle is very straightforward. The polarized light passes through a chiral sample, and it rotates the plane of polarization. The angle of rotation, it will be directly proportional to the concentration of chiral substance and the path length through the sample. The relationship is captured in the formula for specific rotation, and that formula is 100 into alpha upon L into concentration. So this allows us to quantify the optical activity of the substances. This tells that the how much the plane of polarization is rotated when the ray of light passes through a specific amount of optically active molecules of a sample. Therefore, the optical rotation depends on the temperature, concentration, wavelength, path length, and the substance being analyzed. Then we will look towards the types of polarimeter. There are three main types of polarimeter. The very first is Lorentz half-shade polarimeter. The second one is the biquartz polarimeter, and the third one is fully automatic digital polarimeter. The Lorentz polarimeter uses a half-shade device. It uses a half-shade device to compare the light intensity visually. So the construction of the Lorentz half-shade polarimeter, it is like that the polarimeter, it consists of a monochromatic source and a convex length of focal length L. It is placed in front of that, and after the lens, we will also have a nickel prism, which acts as a polarizer in this case. And H, which is a half-shade device, it divides the field of polarized light of the nickel prism into two halves, generally of unequal brightness. The T is a glass tube in which an optically solution is filled. The light, after passing through T, is allowed to fall on the analyzing nickel, which can be rotated about the axis of the tube. The rotation of the analyzer can be measured with the help of scale. So here we will see what is half-shade device. Basically, device, it is made of using two semicircular plates. The one semicircular plate, it will be made up of glass, while the other one will be made up of quartz, and both we will join together. The quartz is parallel to the optic axis, and the thickness of this quartz is selected in such a way that it introduces a part difference of a by 2 in the quartz ray and the glass ray. The thickness of this glass is selected in a way that it absorbs the same amount of light as is absorbed by quartz half. So the determination of specific rotation. In order to determine a specific rotation of an optically active substance, the polarimeter tube is first filled with pure water and the analyzer is adjusted for equal darkness. The position of the analyzer is noted with the help of scale, and then the polarimeter tube is filled with sugar solution of known concentration. And again the analyzer is adjusted in such a way that again the equally dark point is achieved. The position of the analyzer is again noted. The difference of the two readings will give the angle of rotation theta, and the specific rotation, it will be again given to us by theta by LC, where L will be the length of the optical path and C will be the concentration of the substance. The second one was the biquartz polarimeter. The biquartz polarimeter is exactly like that of the Lorentz half-shade polarimeter. Only the difference is that here the two semicircular plates will be of quartz and they will be each of thickness 3.75 mm. One half consists of right-handed optically active quartz while the other will be left-handed optically active quartz. And the third one is fully automatic digital polarimeter. This provides accurate results instantly and supports advanced applications like reaction monitoring and high performance liquid chromatography. Then applications in chemical analysis. Polarimeter is a very important tool which is used in chemical analysis. Its application include the very first is purity determination. Even slight impurities can alter the optical rotation, making polarimeter a reliable tool for quality checks. The second thing is enantiometric axis. The polarimeter helps in calculating the proportion of each enantiomer in a mixture, which is crucial in pharmaceutical industry. The third one is the reaction monitoring. By tracking the changes in the optical rotation, we can analyze the progress of reaction in real time. Then the polarimeter in the pharmaceutical industry. In a pharmaceutical industry, polarimeter, it is used to ensure the safety and efficacy of the drugs by monitoring its purity and enantiometric composition throughout the development and manufacturing. It is used to ensure the drug purity, the drug development, its quality control, and manufacturing. The limitations and sources of error. Despite its versatility, the polarimeter has some limitations. The very first is the temperature effects. The optical rotation is temperature sensitive, so maintaining consistent conditions is difficult. The second thing is solvent. The solvent can influence the measurements. Only pure and appropriate solvents could be used. The third thing is instrument calibration. Accurate measurement require proper instrument calibration, which is sometimes difficult. The fourth one is sample concentration. Errors can arise if concentrations are not precisely known or controlled. So, thank you for your attention.